Okay, there we go. So we have to find feasible region. Would it be 1, 2, 3, 4, 5? Which one is that region? So actually, to find feasible region, we have to solve the inequalities and then graph all the inequalities, right? But inequalities are already graphed right over there. Just we have to shade them. And feasible region is a region where the shaded portions of all the inequalities intersect. Right now we have 1, 2, 3, 3 inequalities, three lines. The first one, let's say it's 2x plus 5y is greater than or equal to 10. And yeah, let's solve the first one. So we don't need to graph it because graph is already given. Just we have to check whether the shaded portion will be towards the origin or away from the origin. So how to check that? To check solution region, we have to take a test point, 0, 0, 0, 0. Just plug in 0, 0. It's going to be 0 plus 0. It's going to be 0 is greater than or equal to 10. It's false, right? If if your test point fails, then you would say the solution, like the shaded portion, is away from the origin, away. And if 0, 0, the test point satisfy the inequality, then you would say the shaded portion is towards the origin. For 2x plus 5y, oh, one thing, they did not mention the inequalities, so we don't know which line corresponds to 2x plus 5y is greater than or equal to 10. Okay, so let's quickly check that. So 2x plus 5 is greater than or equal to 10. We don't know which inequality is that, so we can just find 2 points, 2x plus 5y. We can just solve 2x plus 5y equals 10. And to check that, we can just plug in x equals 0. We would get y equals 2. So 0, 2 is the point. And we plug in y equals 0. We would get x equals 5. So 5, 0 is the point. So 0, 2, 5, 0. 0, 2.
So what you did was just plug in x for 0.
Yeah. And solve for y.
Okay, and then you get that to 2. Or how did you get 2?
Look, to draw the line, we have to just solve the equality associated with that linear inequality. Like we would just take equation 2x plus y equals 10,
Oh,
not
so
less.
like this.
Yes, exactly.
Equal, and then you plug in a 0 to x.
You can take random points to draw a straight line. Keep in mind. You can take x equals 1, 2, 3, whatever you want to take. But the easiest way to find a line to draw the graph, you can just take x equals 0 and y equals 0. Simple. X-intercept and y-intercept. If you plug in x equals 0, you would get y equals 2. It means 0, 2 is the point. And if you plug in y equals 0, you would get x equals 5, means 5, 0 is the point.
Okay, so you plug in a 0 for x to get y equals 2, and then 0
Yes.
for y to get
X.
5.
Yes.
Okay, got it.
Now look at it. Look at these points. So if we draw these points, 0, 2, 5, 0, 2 is right over there, and 5, 0 is right over there. So this is the line. Just coincide these points. So this is the line, right? So that's the first inequality. And the test point says that a shaded portion is away from the origin, right? So it will be something like this. This is the shaded portion for this inequality. Now let's take the next one. The next inequality is negative x plus 4y is equal to 12. If you take x equals 0, y is going to be 3. So 0, 3 is the point. If you take y equals 0, x would be negative 12. So negative 12, 0. Let's take a look at that as 0, 3. This one is 0, 3. and negative 12 comma 0. X is negative 12, y is 0. So, oh yeah, that will be somewhere on the left side, but I think that is the line, right? This is the line. Yeah, it is. Does that make sense? We could take any other point because if you're taking y equals 0, we are getting negative 12. But if we take x equals, let's say, we could take x equals 5, 4, 3, whatever you take. Let's take x equals 5. So negative 5 plus 4y equals 12. 4y, just add 5 on both sides. 12 plus 5 is going to be 17. And y is going to be 17 over 4, which is 4 point something. For x equals 5, we got like 5 comma 4.1, let's say, right? So the first point is 0 comma 3, the second point is 5 comma 4.1. 5 comma 4.1, let's say 5 comma 4. So obviously that will be somewhere right away. This is the point of this line. Yeah, as I told you, this is the second line, this one. This line corresponds to negative x plus 4y is greater than or equal to 12. Does it make sense?
Yeah.
Perfect. Now let's take the test point. Test point. Negative x plus 4y is greater than or equal to 12. 0 comma 0. 0, 0. 0 is greater than or equal to 12. It's false. So for this one, solution region will be away from the origin, right? Not towards the origin. It will be away from the origin. So it's going to be above. You got it?
Yeah.
Perfect. Now, just third line, which is like we don't need to solve because it is already like the last one is going to be this one, right? Which has left. So we don't need to solve it. Just take a test point for that. 3x plus 4y is less than or equal to 28. If you plug in 0, 0, it's going to be 0 is less than or equal to 28. Yes, 0 is less than 28, which is true. It means its solution, its shaded portion will be towards the origin. This is the line, and its shaded portion towards the origin like this, right? Towards the origin. Now, in which region all the lines are intersecting? All the shaded portions are intersecting.
IV.
Yes, fourth region. IV means the fourth, this one. This is the solution region.
Okay, so basically to solve this, you take these equations and then plug in x and y to find out the 2 points. The 2 points for x and y.
Yeah, exactly.
And then you do the test point to see if it's false. So when you do the test point, it's always going to be 0 comma 0.
Yeah, exactly. Always.
Always, like every time. Is it because of this or?
X is greater than or equal to 0, y. Yeah, test point is always x equals 0, y equals 0.
So this
X is greater than or equal to 0, y is greater than or equal to 0 means that you would only deal the first quadrant, right? This represents only the first quadrant. Means x is positive, y is positive, means x and y both are positive in just first quadrant. Because this graph is going on the, left side right over there in second quadrant. This one is going on, right over there, right over there. But we don't need to deal, this portion, this portion, and this portion. Only the first quadrant. Because, you have 1, 2, 3, 4 quadrant. So we would only draw the graph in first quadrant.
Okay. So this equation right here, it doesn't mean anything.
Yeah. You don't need to solve that. Like it just represents that we have to draw the graphs at first quadrant.
Okay. So if it's false, it's away, which is like away from the area.
Away from the origin. Yeah, away from, like, this is your origin, this one. This is origin. This is called origin, this point.
Oh, so is it 0, 0 always the origin?
Yes, yeah. 0, 0 is always the origin.
Okay, I got this one.